recording now. We have, okay, thank you. You help me. We have horizontal asymptote and two conditions, two possibilities. We have the first one is called regular, and regular is when the degree of the polynomial at the top. Suppose this example: f of x is equal x squared minus 5x plus 6 over x squared minus 3x plus 9. Entonces I saw que the degree of the polynomial, degree of the polynomial on the top is 2, because of the higher exponent, no? And the degree is, and the bottom is also 2, no? Therefore, in order to find what is the position of the horizontal asymptote, you consider only the dominant term, que es the term que contain higher exponent, and you ignore totally the part I highlight in blue and green color. So mine and behavior would be x squared divided by x squared. X squared divided by x squared 1. Therefore, the horizontal asymptote is located at the position y equal. Okay, this is the regular, the most common case. However, unfortunately, we have a special case. A special case. And a special case is when the suppose this function, suppose que the polynomial and the top is 0, the degree is 0 because it's a constant 10, degree 0. For example, no necessarily any polynomial. But the characteristic that most important is the degree of the polynomial at the bottom is greater than, not equal, greater than. Greater than x3 plus 2x plus 6. Degree 3. In this case, the degree of the polynomial and the denominator is greater than. Therefore, we have the horizontal asymptote also we have, pero at y equals 0, always 0, because it's special. Okay, and the value que resolve for the division of the coefficients, well, is when the degree is the same. That's it. No more possibilities. We have regular, number 1, special, number 2. So you need to be aware that we have two possibilities. Okay, so let's move on to the one example today. Okay, bring to illustrate a little bit different thing about the horizontal asymptote, but a little bit different. Okay. Let me erase the board. Boom. Suppose this example number 1 of today. The function is called h, and is 8x squared plus 9x minus 5 divided by 2x squared plus 1. Okay, this is the expression that is given. I want to investigate, determine if the graph have or not the horizontal asymptote. Okay, the question is, number 1, we have or not horizontal asymptote. The second is where. In the case that we have yes, where. In the third case, is the new situation that I want to discuss now, where a graph of the function, the original, crosses the horizontal asymptote. Okay, this is a new situation that sometimes Never happen in the vertical asymptote. Vertical asymptote, never. The curve, when you're talking about curve, is a function, no? That function represents a curve. So this curve crosses. It's a new situation. Okay, to answer, the first question is yes or no? Number one, yes or no? Yes or no? Our function is giving half horizontal asymptote, yes or no?
Yes.
Hey, participation. Participation.
Yes.
Yes. Why? Reason.
The degrees are equal, 2 and 2.
Exactly. Exactly. This is the answer. Because degree is equal. Yes, the answer is yes. And the reason to explain que es yes is because degree of the numerator is 2. And degree of the denominator is also 2. Okay, this is the analysis, right? Analysis of the degree. Because degree is the same. Are the same. The same. Okay. And no is incorrect answer. Boom. Now number 2, where? Where? Where is located the asymptote? At y equals something. Because remember, the horizontal asymptote is a horizontal line. And any horizontal line equation is y equal a number. What is this number?
4.
4. Where come from that 4? Because, give me a reason, miss.
8 divided by 2.
Because 8 divided by 2. 4.
Exactly, 8 divided by 2. That 8 and 2. Nice, perfect. Okay, now the next problem is identification if my curve crosses or not the horizontal. Sometimes this happens, but seldom, not frequently, not often. But we need to investigate always. Okay, because this represents important point. And number 3 is I want to investigate if that function is h of x is equal somehow or somewhere equal 4, is the value of the asymptote. So you set out that equation. Ax squared plus 9x plus 5 minus 5, sorry, divided by 2x squared plus 1. So I need to focus it to solving this equation. In the majority of cases, this equation have no solution. Does that mean the interpretation that we have no any point that they could cross it? In other case, yes, cross it. See, this equation have solution. So to find the solution is relatively easy because you apply cross multiplication. You multiply 1 times this equal 4 times this. Okay, it's much better, at least for me, to see the equation. So we have ax squared plus 9x minus 5. And you distribute it here. Why not? Because I want to remove a parenthesis, no? Okay, plus 4. Okay. Now I can see, wow, look at that, easy. That part is canceled out. Simplification. This and this is say goodbye. And our equation is not quadratic, it's linear equation. So 9x minus 5 equals 4. 9x equals 4 plus 5 equals 9. Divided by 9. X equals 1. Oh, so we found that our curve crossed the horizontal asymptote at the point 1 comma something. Okay, if you want to express it, the point que touch. So physically, suppose, I don't know, I have no idea. Bueno, case, you determine that the horizontal is located in 4. 1, 2, 3, 4. So normally in the sketch that we are doing in the test, you put dotted line to indicate the the horizontal line, y equals 4, let's say horizontal asymptote. However, our curve, I prove que touch in one. So one here, x-axis, is a y-axis, no? 1 comma something. Okay, I have no idea how it look like, but on my curve, using maybe decimal, whatever, look like that. Whoa, boing, and continue forever. And this approach, pero never touch. Yeah, he approach, pero never touch. This is classical of the horizontal aspect. Remember, it's the end behavior when the x approaches to infinity positive, or when the x approaches to infinity negative, in opposite direction. But this is important point. The point is the point 1,4. Because when from that 4, 104 is the value of the horizontal aspect. That's it. Do you get the idea? Any question? Any question? Any question? Clear or confusing? Clear? Eso, bueno. Roy say, clear, professor. Okay, go ahead. So let's study the last one, kind of asymptote. Clear. Okay, Dylan. Let's study the last kind of the asymptote. It's called slant asymptote. Slant. How do you know when you have a slant asymptote? How do you know? We have a slant. Well, you have a slant when the degree of the polynomial in the top. So remember P and Q. This is our typical format for the rational function. No? This is f of x, rational function, division to polynomial. However, the degree of P, the numerator, is greater than the degree of Q, but it's greater than in only one unit. Okay, suppose si you set out like a no inequality, no equation, degree of P is equal degree of Q plus 1. I don't know, for example 2 of today. Suppose the function f of x is equal x squared minus plus 1, it's p, divided by x minus 1. So immediately, I analyze the degree analysis. Degree of the polynomial on the top is 2. Degree of the polynomial on the bottom is 1, linear. It's obvious that we have no horizontal. The horizontal only we have when it's the same or the degree of the top bottom denominator is bigger. But in this case, degree of the numerator is bigger than 1. So we have slant. This is the condition. Your identification, is extremely important. This condition, horizontal and slant, these are mutually exclusive. Si we have horizontal, we have no slant. Si we have slant, no horizontal. But no both. Impossible to be both. It's obvious, right? No horizontal. In that case, yes, slant. Okay. But what is the formula for the slant asymptote? Because in the horizontal it's easy, it's y equal one number, no? But in this case, I have no idea. So now, for finding the equation for the slant is easy. You perform the long division, okay, of that polynomial, long division. You can do the long division. Exactly the same when you are doing in elementary school, no? You divide, for example, 5 divided by 2 is 2, 2 times 2 is 4, subtracting 1, okay? And this is 2, 1.5, something like that. Remember the procedure, the algorithm of the division is different multiplication and subtraction. So you divide, the divisor is the denominator, que is x minus 1. You put outside the box. In this case, I divide 5, division 2, no? There is a reason that the format was this. Divisor is this guy, divisor. I put outside, and dividend is the guy inside. Dividend, dividend, dividend. And when you write the dividend, you try to complete the some term gets missing. For example, x squared is that guy. Plus 1, so 1, the linear term is missing. 0x plus 1. This is important. Extremely important, complete the missing using 0. Because this helps me to keep the order of the division. Okay? Okay, let's do it in the division. So now I try to find one expression here. Can multiply by x, give me x squared. Let's solve this x. Because x times x is x squared. Now multiplication, x times x, subtracting, change the sign. Multiplication, this and this is minus x, subtracting, change the sign, plus x, plus 1x. Now subtraction. It's obvious that that part is cancelled, always happen. I create this condition, of course. And 0 plus 1 is 1x plus 1. And stop here. No, no, no. No, no. Why not? Because you stop when the degree of the remainder, get this guy, remainder is the degree of the remainder. In this case, the remainder is x plus 1, and the degree of 1. So the degree of the remainder, look, the degree of this polynomial is 1. And the degree of the divisor, que this polynomial divisor, the degree is also 1. So no, stop. Because you stop when the degree of the remainder is less than the degree of the divisor. So the degree of the divisor is 1. I stop when the degree of the divisor is 0. So no x, only constant. So we continue the division, the long division. So is plus 1. The plus 1. Because 1 times x is x. By subtracting, change the sign. And 1 times negative 1 is negative 1. By subtracting, is plus 1. And this is cancelled, as always, and this is 2. So conclusion. What is the conclusion? Well, the conclusion is the rational function gets given in that problem, we can write in that way. A quotient, this expression is quotient. Okay, you copy the quotient, that's x plus 1. Plus the remainder, okay, this guy, remainder, okay, que 2, divided by divisor, que is x minus 1. So these and these are perfectly equivalent, algebraically. It's similar to this. You divide 5 divided by 2, but when you write mixed numbers, 2, 1.5. 2, 1/2. Okay, this is the quotient. This is the remainder, and this is the divisor. Exactly the same. However, in that case, that part represents the slang asymptote. So the formula for the slang is y equal x plus 1. And this is the way to find the slang. And slang asymptote is, well, it's a line, but no horizontal line. No. Oblique line. Okay, entonces suppose que we are doing like that. XY. You plot the slang asymptote, it's super easy because I suppose you remember the formula y equal mx plus b. Is the equation of the line, no? B is 1, so passing through the point 1 gets the y-intercept 0,1, and slope is also 1. M is 1 and B is 1, both is 1. So roll and rise, 1 up, 1 to the right, and you are doing the slant asymptote. Y equal x plus 1. And by curiosity, this is completely complementary idea, no the thing that we are discussing now. I can see that part is important, and that part have one vertical asymptote at x equal 1. So at x equal 1, okay, 1 is here in x-axis, we have one vertical asymptote. Guys, this is vertical asymptote at x equal 1. And this is slant asymptote at no point, is this formula. Okay, so now well, you put in decimals or you are doing by hand. After I want to explain the idea, but the thing I want to discuss is I put in decimal. In decimal, I get something like that. This is the curve. That curve represents the original equation. That equation, look, that equation. But the important thing I want to discuss now is determine the equation for this line asymptote. So this line, this is the important thing now. I promise today I bring 3 examples to integrate everything. Can you see what is the methodology to analyze step by step the rational function? Okay. Any question about this line? Do you understand this line? Okay. Do you understand long division? You remember it well or you don't remember long division?
With the division is kind of iffy.
What's the confusion part, Holmes? What did you say? Repeat again, please.
I'm not sure. It's how you know which ones to divide by. How I don't know. I'm not sure.
Divided by half. A ver, what part? It's confusing. Okay, let me try to indicate. This is the part that you don't understand very well. Huh, Holmes? The
Yeah.
part yeah. Okay. Okay. Try to compare in your mind this division and this division, no? So now I determine okay, the quotient part. Quotient. What is the quotient part? Well, the quotient part is that part. Okay, you have in that position in the format of the long division, no? Is x plus 1. Look at that, x plus 1. You copy that, x plus 1. And this is similar to these two in this numerical division. Now plus. Okay, the formula is quotient plus remainder over divisor. That's the formula. In our specific example, the quotient is x plus 1, boom. The remainder in the long division is 2, boom. I copy here, look at that. And the divisor is this expression, x minus 1. I copy that. Boom. That's it. Got it? Yes or no? No, but don't worry. Let's do another example. Another example to practically be long division, and you help me to understand the asymptote in that case. We focus now in the asymptote part after we integrate everything to make the elegant graph of the rational function. Okay, example 3 now. Example 3 say, look, the function g is given is equal to x squared minus 5x minus 3 divided by x minus 2. Again, the classical question. What kind of asymptote we have? What kind of asymptote we have? Well, you say, well, professor, wait. At least I saw that we have vertical asymptote. How do you know? Remember the idea for the vertical. Vertical, you take the polynomial in the bottom. You put x minus 2 equal to 0. So at x equal to, we have verticals, for sure. Because when you are doing the sketch of this, into 1, 2, you put a dotted line vertical. This is vertical asymptote at x equal to x-axis, y-axis. My next question is, we have horizontal asymptote, yes or no? No, yes, no, yes, no. Remember the analysis of the degree. We have horizontal, yes or no? Regular and special case. We have no, yes, no. Come on, participation. Come on. No idea. Are you there?
No.
No, why no? What is the reason que no? She said no. I
The
agree with
degrees
her.
are not equal.
No equal, and another possibility is it's not the same. Okay. Listen to me. We have two possibilities. Exactly. Degree no equal is not the reason. Because we have horizontal when the degree is different, but degree of the denominator is bigger. But in this case, no. In this case, the degree of the denominator is 1. Degree of the denominator is 1. Okay, degree of this guy is 1. And degree of this is 2. To satisfy perfect the condition for the slant asymptote, okay, is when the degree of the numerator is bigger than 1. So the answer is slant asymptote, yes. We have. No horizontal. And this is mutually exclusive. When you have slant, we have no horizontal. When you have horizontal, we have no slant. So now in order to find the equation for the slant asymptote, you have to divide. Long division format. You copy the polynomial in the top is 2x squared minus 5x minus 3, and you divide it by x minus 2. Okay, let's do it. It's obvious the expression here is 2x, because 2x times x is 2x squared. By subtracting, you change the sign, always. And 2 times 2 is minus, but by subtracting is positive 4x. Cancel out that part. This is negative 1x. Bring down the last digit, okay, 3. Now it's negative 1, because negative 1 times x is negative x. But by subtracting, you change the sign, and negative positive by subtracting is negative 2, no? In that case. So this is cancelled, but this no, it's negative 5. My expression is given at the beginning, okay, is 2x squared minus 5x minus 3 over x minus 2 is equivalent 100% to say 2x minus 1 minus 5 over x minus 2. Remember, this is the quotient, is this. This is the remainder, is this. I put negative 5, I put negative outside. Doesn't matter, you put plus minus, doesn't matter, it's the same, right? And this is the divisor, this. Because I can see clear like a water, okay, this is my slant asymptote equation. So the equation is y equal to x minus 1. You want to do the graph of the slant? Well, you know, okay, the equation for the line, you know, is y equal mx plus b B is -1, compare this equation and this equation, B is -1, that means that the y-intercept of this line is -1, so 0, -1 here, over there. 0, -1, and the slope is 2, because this coefficient is in front of the x. Therefore, it's 2 up, 1, 2, and 1 right. Boom. And you determine the slant asymptote graph. This is y equal to x minus 1, and this equation is x equal to. This problem, we have two kinds of asymptote. We have vertical asymptote and we have zero. Okay. I suppose que no bad, eh? Now let's practice. Integration, everything at the beginning. Entonces, I propose you. Bueno, any question in this example? Yeah, you see clear or no? Holmes, you see clear? Let me check it.
For some reason, when you do the long division, I always get lost. I don't know why.
Well, good question.
Can you go over it one more time?
I do the long division because, listen to me. I know I need to do long division because the degree, so this fraction is improper fraction because the degree of the numerator is bigger than the degree of the numerator. It's similar. You have, for example, in arithmetic, elementary school, that fraction, 5/2, is improper because the numerator is bigger than the denominator. So now we have the possibility to divide. 5 divided by 2, something, 2 times 2 is 4, subtraction, 1 is 2, 1.5. However, another fraction like that, 1/2, is proper. This is improper.
I get that part. I'm talking about like the actual, when you do the actual division, like with...
Is the part that you don't understand?
Yeah.
So I repeat again
Please.
The story. Look, I repeat again the story. Do you understand that I put in the, yes, the division is confusing. Okay. I suppose that you know that. You see, sometime in your life, maybe you don't remember, no problem. I explain, don't worry. This is easy. Only focus. Are you clear the position of the polynomial in the long division format or no?
Yes.
Okay, the position is clear. So now, Horse, look at that. You determine one expression, boom, okay, you have an idea, question mark, can multiply by x, give me 2x squared. It's obvious, at least for me it's obvious, okay, 2x, no? Because 2x times x is 2x squared. I need to find one expression, can multiply by the first, give me exactly the first term in the polynomial inside the box. So you multiply this and multiply this, one by one. 2x times x is 2x squared. But you need to subtraction, and when you subtract 2, you change the sign. And 2 and -2 is -4. -4x, by you subtracting, you change the sign. Do you follow me?
Yes.
Eso, bueno. Now cancel out that part. I create intention, always happen to cancel out the first part. And it's a -1 minus 3. Bring down the last digit. Now what is the expression again? What is the expression? Get multiply. Forget about that part now. This arrow is not important now. I need to, again, repetition, the same procedure. I need to find something. Can multiply by x, give me minus x. Well, it's -1. It's -1, entonces es -1. Because I know que -1 times x is -x. By subtracting, change the sign. And -1 and -2 is +2. By subtracting, is -2. This is cancel out, always happen, and it's a -5. Done. End the story. Any question?
I get it.
Got it. Okay, super. Okay, no problem. Now let's move on to the important motion. Important.
Thank you.
No, man. This is my pleasure. I enjoy teaching. You know? Okay, because now, well, the procedure that we are doing for doing the graphic. So my goal is graphing a rational functions. Okay. Procedure, step by step. Actually, we have 7 steps. I respect that order. Number 1 step is they are polynomial with no common factor. What mean that? Well, easy. You have one polynomial, suppose, I don't know, x squared minus 5x plus 6 divided by x squared minus 3x plus 9. And you factorization is the first thing. So express it in factorial form. Xx 3 2, no? Because 3 times 2 is 6, 3 plus 2 is 5, and this is 3 3. Sorry, this is 6. To do perfect, this is 3 and 3, and negative both, no? Because 3 times 3 is 9, and 3 plus 3 is 6. This is minus, 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 minus. And you can see, wow, look at that. That factor and that factor is cancelled. That is the reason that they are polynomial with no common factor. Last bracket. Last bracket. Yeah. Last bracket. X here. And the problem is that when I underestimate something, okay, I suppose it's straightforward. Because I do it fast, because I make a mistake. Okay, so basically, my expression is not like that. It's like that, x minus 2 over x minus 9. But I know okay, we have a whole at x equal to. Well, in this case, a coincidence. Well, suppose another case, not 3, it's 4 here. Another number. 12 and 7. Okay. You factorization, so basically, you factorization the polynomial at the top, the polynomial at the bottom, and you cancel out the factor that is repeated, is common. Okay? So now you working, so you continue with step 2 with the new expression that have no common factor. The common factor is cancelled out. And I know that we have in this factor that is gone as a whole. Do you understand this step or no? Do you understand this step or no? Okay? The first thing you should do, So people, no. Factorization is the first step. Bueno, no always happen that we have common factor. See, we have no common factor, okay, no whole, that's it. We have common factor, you cancel out. You're working with the new one expression with no common factor, but under the consideration that we have a whole and the factor is cancelled. In this case, 4 here. Okay, number 2 step, easy. Compute Y-Intercept, because Y-Intercept is always important point in any function. In any graph that we are doing, it's important. And what is the formula? I don't remember. I remember. Evaluate the function is 0. Okay, evaluate the function is 0. And number 3, compute X-intercept. And what is the formula? The formula is using function notation, f of x equals 0. But notice, we are working with the rational function, and the rational function is division to polynomial. And when it's equal to 0, it's because the top part is 0. It's because this is equivalent, equivalent to say que P of X es 0. Y I don't care that part. It's totally irrelevant in the problem. Okay, because you know 0 divided by anything is 0. I don't care, it's fine. Okay, so basically you take the polynomial at the top, you enforce it to be equal to 0, and you solve in this. Maybe si es, you know, si es quadratic, you have two solutions, so we have 2 points. Si es another, we have more points. But this is the solution of the P of X equal to 0. This is a formula for finding specifically a rational function the X-intercept. And the formula for finding the Y-intercept is easy. It's just arithmetic. Evaluating 0. That's it. Number 4. Number 4 is important. Is find vertical asymptote. So what is the formula for the vertical asymptote? Well. Remember, our function is P of X over Q of X. And this is undefined in 2 possibilities. Or whole or asymptote. Vertical asymptote. It's undefined. In both cases, undefined. So you take denominator, que Q, equal to 0. This is the formula for finding the vertical asymptote. You take now the polynomial in the denominator, you enforce it to be 0, and the solution of this represent the vertical asymptote. Well, after, I don't know, see, you know, the behavior is like that, or like that, or like that, or like that. This is after the behavior. This is after. But at least I have in my hand the asymptote. Yeah, I put a dotted line, vertical dotted line. This is a moment that I want to start doing the graph. And this moment, this is a moment that, in my opinion, I don't know you start doing the graph. So I put a rectangular coordinate system, I put a vertical asymptote, I plot that point here, on the x-axis because it's x-intercept. I plot that point, and normally it's only one, y-intercept. I have some idea, roughly idea, how it look like our curve. No total, but some idea. Okay, number 4. Number 5 is the continuation, que es obvio que es find horizontal asymptote or slant asymptote. What should I do? Well, you are doing the analysis of the degree. Analysis of degree. And you know, I want to repeat again, but see the degree is the same. So horizontal is 2 possibilities. Same degree or degree P, degree Q, greater than degree P. Okay, this is regular, and this is special. You need to be aware for both. Now, it's important, don't forget, in this moment, determine if the curve crosses or not the horizontal asymptote. So determine potential point when the curve crosses the horizontal asymptote. Well, another possibility is, well, this is a horizontal topic, but sometimes it's slant. And this is completely disjoint. See, we have this mutually exclusive. See, the answer is this is yes, the answer here is no. See, the answer here is no, the answer here is yes. Not necessary, but frequently happen that. Because you are doing now long division. Exactly what you see in the example. Economic, I believe, more example. And also in the review packet, we continue doing more example. And you determine the formula for the slang asymptote that look like a linear equation. Okay, super. And that's it, Professor. No, we have 7, no? Well, this is vertical. Number 5 is horizontal and slant. Que hay condensed in only one because there are mutually exclusive. You have horizontal or slant, no both. And number 6 is important, in my opinion, super important. And the student forgot. It's the test of symmetry. Test of symmetry. I want to explain what is important. Entonces, remember, in the other chapter, we studied the function even, the function odd, or the function neither. The condition for even is when you are doing reflection, the function stays the same. In other words, the positive part and the negative part are the same. When it's odd, when you are doing reflection, it's opposite sign. In other words, the positive part and the negative part is the same, but in opposite direction. And neither is no law, totally arbitrary, no important. So now I take advantage the test of symmetry because suppose that you are doing a complicated graph. I discover that we have here one horizontal, one vertical asymptote and 2, another vertical asymptote and 6. We have one point here in 4,0. Y hay proof que the function is even. Well, entonces the negative part is exactly the same of this. So we have one vertical asymptote and -2. We have another vertical asymptote and -6. And this point, 4,0 is located in the point -4,0. I save time because I know that the graph is completely symmetric with respect to the y-axis. Okay? In this case, is similar. This is the even case. The odd case is similar, but in the point, suppose that I determine one point here. And that point is the point, this is 6, this is 7. 7,4. Suppose que it's odd. When I plot the point, 7,4. Nice. When you plot in the odd, it's -7, it's -7, -4, like that. -7, -4. So like that, look. Like that. Because it's negative. This is an odd case. And even no. And even the same. Suppose que 7,4. The point is the point -7, +4. So the y value stays the same, doesn't change, completely symmetric. In this case, opposite sign. It's the same value, but opposite sign. Suppose you are doing the graph like that, the other graph is like that. It's completely the image, but in other direction. It's symmetry with respect to the origin. In this case, symmetry with respect to the y-axis. Do you understand the importance of the symmetry? Clear, guy, or no? No? But I want to, Professor, you said you have 7 points. Yeah, the last point is plot additional points. Additional points. But how many points, Professor? 1, 2, 3, 4, 5. No, depending. Look, suppose, let me explain in detail this, que look like trivia, pero no, it's not trivia. Suppose que in this moment, you are determining, for example, two vertical asymptotes. Vertical asymptote number 1, vertical asymptote number 2. And you determine also this point, and this point, and this point, why not? Que is the Y-intercept, the X-intercept, sorry. X-intercept. By the way, by definition, x is the point in which the curve crosses the x-axis. Entonces, how many additional points we need in this example? Well, I suppose that we need to investigate, for example, and between this point and this point, you pick one, arbitrary. And between this and this, you pick one, arbitrary. And between this and this, you pick one. And by the way, in my opinion, the easy would be 0. And between this and this, 1. And between this and this, 1. And after this, 1. And after this. No, exactly. But this is super easy. Determine the point because you pick the x value and you plug it in the function notation and you get the y value associated with this. Do you understand or no?
Not really.
What part you is confused? Come on, discussing. The last part, the additional point?
Yes.
Okay. Do you see in the example? I promise you see in the example. But the question is, Professor, how many point addition I need to plug? It's up to you. It's no strictly mandatory, depending on the example. Entonces, my recommendation is select arbitrary point, x value, in the specific interval in between, for example, 2 points that you well know. For example, X-intercept or vertical asymptote. You pick 1 point and you evaluate and you get the y value. Plot this point. I plot that. Suppose that this, I plot that. Suppose that this, I plot that. So I have one idea how it look like my graph. My graph look like that. Okay, don't worry. I want to illustrate in few minutes immediately when the specifics. Any question about the point? 7 point, guy. 7 point. Okay, let's move on to the first completely, totally example. Okay, summarize everything that we are discussing. This is example. I don't know. It's 1, 2, 3, 4. 4. Suppose the function is given. The function is 4x over x squared minus 1. And the question says, do the graph of this. Do the graph of this. Okay? Pero complete the analysis. Step 1 is factorization. The factor 4 is 4x stay the same, but this is different of a square. And the factorization is xx 2 plus or minus. Okay, super. This is the factor 4. Factory 4. You can see that we have no common factors to do simplification. That means that our function have no hole. No hole. Nice, I like that. This is step 1. Step 2 is compute the Y-Intercept. To compute the Y-Intercept, you evaluate the function in 0. Substitution, plugging in 4 times 0 divided by 0 plus 2, 0 minus 2. 4 times 0 is 0. This is 2, and this is negative 2, and negative 4. So 0 divided by negative 4 is 0. When this situation happens, frequently happen, when the answer is 0, it's because the Y-Intercept is the 0,0 point, the origin. And this is both. This is X-intercept and Y-intercept. But maybe X-intercept have another value or no, I don't know, depending on the example. X-intercept is the next topic, is the function evaluated in 0. It's equivalent to say you take the polynomial equivalent. You take the polynomial at the top, it's 4x. You ignore completely the bottom part and you enforce it to be 0. And we get exactly the same answer. 0,0 is both. It's Y-intercept and X-intercept. Everyone follow me so far? Everyone follow me so far? And doing too fast? Yes. Okay. What's the fourth step? the fourth step is compute the vertical. And the vertical is easy. The vertical is you take the polynomial in the bottom, either way. You take the factor 4 or no, or the original, either way. For example, I take this or this, either way. Let's do it in both ways. You see that there's no difference. You take x squared minus 4, you enforce it to be 0, and you solve this quadratic equation. And this quadratic equation is x squared equals 4. Apply square root both sides, exactly the same we are doing in the chapter 1, x plus or minus 2. Entonces now we have 2, 0. No, 2, 0, no, it's no point, it's the vertical. It's the vertical asymptote. We have two vertical asymptotes, sorry. Plus or minus 2. Vertical asymptote number 1 is x equal to, and vertical asymptote number 2 is x equal minus 2. Suppose another student taking this expression, taking this. It's the same, look. Equal to 0, that means that this factor is 0 or this factor is 0. Solution is -2 or positive. And we get exactly the same result. So this is a moment personally I like to start doing the graph. I don't know why in this moment I feel comfortable. Of course we are doing decimals, but no, okay. Let's do a little bit by hand. Okay, what the thing I have in my hand? Well, in my hand I have the only point is the 0,0. I plot that 0,0. This is the Y-intercept and X-intercept both. What more information we have in my hand? We have the vertical asymptote, and the vertical asymptote is in 2 and -2. 1, 2, 1, 2. And the vertical asymptote always will represent dotted line vertical. In this case, I put in blue color. I don't know why. Blue color. Just I have some idea how, well, approximately. I have, this is information that I have so far. Everyone follow me? Number 5. Doing the analysis of degree, we determine if we have horizontal or slant. What do you think? Horizontal, yes or no? Slant, yes or no? Come on, with participation. I need help. Nobody know? You are here, you pay attention or no? Come on. You are students, you make a mistake, no problem.
Is it no horizontal or slant?
No horizontal?
No.
No horizontal, no. Everyone is agree or disagree? No horizontal, he said. And slant? And slant?
Yes.
Yeah, you are wrong. Totally wrong. Because remember, yeah, no problem. Remember, degree of this polynomial is 1. Yes or no?
Yes.
Degree of this polynomial is 2. Entonces we have two possibilities to have horizontal. When the degree is the same, it's not the case, or when the degree of the bottom is bigger than the degree of the top. This is yes, it's yes, it's pero special. It's special case. Okay, I want to repeat again. Repetition, guy. I know que maybe you don't memorize right now, but you have to in one moment, no? We have horizontal in 2 cases. The regular is when the degree is the same. No, it's not the same in this example, no? But we have also when the degree of the polynomial in the denominator is greater than 1, 2, 3, doesn't matter. Entonces es especial, you know que es especial at y equals 0. This is my horizontal asymptote. Entonces I do that line, que the horizontal line exactly coincident with the x-axis. Okay, this is my vertical asymptote 1. This is my vertical asymptote 2. This is my horizontal asymptote. Only one, que es the only one que I have. Okay. Do you see or no? Do you see or no? Do you see or no? Eso. Que me dice, yes, I saw. Okay, okay. What is the next step? Symmetry. I need to prove somehow que my function is symmetric or no. Si es symmetric, don't be sad, because the only thing is that you are doing the graph of the negative part completely different of the graph of the positive part, and that's it. But si es symmetric, I take advantage. So now I take the original function, que es this, f of x equal 4x over x squared minus 4. I copy again the original. Here I perform reflection. How? Replace x for negative x. You know that. It's a transformation. The 4 times negative x divided by negative x squared minus 4. 4 positive times negative x is negative 4x. And this guy square is positive, stays the same. I can see now that this expression and this expression will look like similar, except that we have a negative here, and I want to put it in the front to see much better. Okay, so you compare, please, to understand the symmetry. See, we have or no, this and this. A symmetry, and what kind of symmetry? Even, odd, or neither. What do you think? What do you think? We have symmetry or no? See, we have symmetry. We have no symmetry. It's neither.
Is it all?
It's all. Very well. Very, very well. It's all function. That means that the point I plot in the next step in the positive part is exactly the same in the negative part, but the opposite side, the y value. So what value you select? Well, let's see. I have no idea. Let me try to use my common sense. Now, Holmes, it's a moment that you understand much better the selection of the point. Remember the point 7, I want to write here, 7, is additional point. How many additional points? Well. You select, for example, one arbitrary point in between 0, that is the y and x-intercept, and 2. I select 1. Why not? And after the 2, I select maybe 3 or maybe 4, either 3. Entonces, en negative 1 y en negative 3, si I select the same, I don't need to repeat because I take advantage of the symmetry. Let's do it quickly. Look, you evaluate the function in 1. What function? The original. The original is 4 times 1 over 1 squared minus 4. 4 times 1 is 4. 1 squared is 1 is minus 3. Is negative 4/3. If you want to see more clear, you put in a calculator, or either way, and you convert like a decimal. Yes, negative 1.3 repeated. And you plot that. You plot this. Negative 1, suppose here, negative 2, I suppose here. Negative 1.3, I don't know exactly, look like that here. Espérate, en red color. This point is that point, que es the point 1, negative 1.3. Okay. Entonces I take advantage of the symmetry because I know that if you evaluate the function in negative 1, it's exactly the same value but the opposite side because it's odd function, 1.3. When I plot that, I put negative 1, and this is 1, and this is 2, 1.3, look like here, and this point is approximately negative 1, 1.3 positive, repeated. Okay, super. Let's do it in 3. Why not? F in 3. is 4 times 3, and 3 squared minus 4. I take the original equation again, plug it in 3, evaluating 3. This is 12 over 9 minus 4 get 5. I put in a calculator. 12 divided by 5 is 2 point something. 12 divided by 5 is 2.4. It's 2.4. I plot that point. So that point is the point 3, 2.4. This is 2, this is 3, 2.4 approximately over there. That point is the point 3, 2.4. However, we have another point que es negative 3, negative 2.4. Que is, well, this is negative 1, negative 2, negative 3, 2.4 approximately over there. Completely symmetric. This is the point que es negative 3, negative 2.4. Okay, now you need to plot more points. You can if you want, but in my opinion, no. Because I take advantage the auxiliary construction of the asymptote. And look, my curve passing through that point, and approach it to the vertical asymptote, but never touch. And similar happen here. My point, my curve passing through that point, approach it to the vertical asymptote in the opposite direction, and approach it to the horizontal asymptote in another direction. And this continues forever. And on the other side, exactly the same. But here, over there. Bam! And this is my graph. What is my final answer? This is my final answer, guys. Sorry, I know it's too long, but you can do that using decimals. I want to show you now using decimals. Any question? Any question? Let's move on to decimals to see more elegant picture. And you can use it decimal anytime, you know, right? Okay.
Will we do an example next class with a slant?
See, yes, of course. This is the first example. I promise again, next time we are doing 2 more examples and we start new section. Okay? But let me see if you see or not. Oh, yes, you see. Look. Let me share the screen. Decimals now for you. Do you see or no? Do you see decimals? Okay, look, what's the example 5? I copy the expression. You can put here y if you want y, or f of x or g of x. An important point was 0,0. Okay, this is the curve. In blue color, look at the curve. And the auxiliary construction to see more clear the curve is the vertical asymptote. Look at that. I flashing that. Vertical, another vertical, one horizontal on the y, on the x-axis, sorry. And a different point que I plot. The 0,0, que is y and x intercept, and another additional point. In this case, I compute 1, 2, 3, 4, 5, 6 points. Additional. Any question? Entonces now in the test, when you are doing the graph, don't forget that the asymptote, you're using always black color, dotted line. The curve, we using the color that you prefer. I using blue, but suppose that you're using red, you can change the color here. You click in the icon, using the left click, and hold the mouse, and you see the color that you prefer. Entonces now, in the moment you want to send me the graph for the test, you click here, you export like a what? Like a image. Download in format PNG. Que es the format que sí, everyone understand very well this one. You download, I don't want to do. I'm supposed to explain one time this. Do you follow me?
What's the point in between -1 4/3 and 1 4/3? Like, you see what I'm saying?
That
What
one.
are those three?
That one. Do you see my mouse? Of course. That one. -1, comma.
Oh, okay. I'm thinking it's two different
No,
combos.
it's the same.
I
It's the
get
same.
you. I
It's
get
the
you.
same. That point is the point. -1, comma 1.3 repeated.
Got it.
And it's Any other question? Any other question? Okay. Let's do another problem. We have time. Yeah, we have 5 minutes. And in 5 minutes, I am capable to do another problem. Because you know the procedure. Right? There's no. Do you see the whiteboard? No, not yet. Do you see the whiteboard? Yes. Okay. Let's move on to another example. This is more interesting. More interesting. Suppose this. Example number 6. No, era 6. Gilan. Okay, yes. Oh, not good. Example 6. Okay, example 6 is g of x is equal to x squared minus 3x minus 5 divided by x squared plus 1. Okay, super. Let's do it. Factory 4. Step 1. Factory 4. Do factorization of g of x. You factorization the trinomial on the top, and you factorization the binomial on the bottom. See if possible. So let me try to do here in one corner. 2x squared minus 3x minus 5. There are several ways to do this factorization. The way I prefer is this. You multiply that number, 10. Doesn't matter the sign is not important. And you try to find the combination that open the door. Okay, 5 and 2. Because 5 times 2 is 10 and 5 minus 2 is 3. So now you split 3. So you bring down 2x squared. You bring down -5. And the middle term, you split like using 5 and 2 in that sign. Minus 5x plus 2x. Do you see the transformation or no? Because I know that this and this together, see you combine later, we come back at the beginning. But no, I don't want to do this. Okay? Now, what is the idea? The idea of factorization by grouping. So basically, the thing I did was convert trinomial, 3 terms, trinomial, and polynomial que contain 4. 1, 2, 3, 4 terms. And you apply factorization by grouping. You select 2 couple, and the GCF in the first couple is x. Open new parenthesis 2x minus 5. And the GCF in the second couple is 1, because we have no common factor. 1, 2x minus 5. 2x minus 5. I factor out one more time, and in the last parenthesis we have x plus 1. Guy? I remember, I suppose that you know that because this is the intermediate algebra. Don't worry, if you have any questions, I can explain again, or another example. This is the factorization. The top part is 2x minus 5 and x plus 1. That was the factorization, the trinomial in the top. And the binomial in the bottom is x squared plus 1. Not good. Because I know the difference of a square, when it's minus, the factorization is a plus b, a minus b. But when this is sum of the square, it's impossible to do anything. It's prime. Therefore, this expression is prime. And leave it like that. Boom, this is the factor form. The only possibility we are doing is the factorization of the trinomial and the top. The factorization, the bottom, no, it's impossible. It's primary expression, primary expression. Do you understand this or it's confusing? Huh? I suppose, in my theoretical mind, you know factorization trinomial and you know factorization binomial. But I refresh your memory so you don't remember, no? Okay. Okay. Any question? No question? So stop, because